Right, so right now, as you're sitting there watching this, physics has already worked out something pretty mental about you. You can't die. Not properly. Not really. And the wild thing is, once you actually understand why, once it sinks in, you might wish you could. Because the kind of immortality that physics has accidentally stumbled into isn't the warm, fuzzy afterlife your nan promised. It's something colder, weirder, and honestly, once you sit with it for a minute, a fair bit more disturbing than just switching off into nothing. Stick with me, because by the end of this video, the way you think about your own existence, the actual you, sitting in that chair right now, is going to feel different. I'm Mohammed, this is Curious Physics AU, and we're about to take a Feynman-style walk through one of the strangest ideas hiding in plain sight inside modern physics. Let's start with a question that sounds dumb until you actually try to answer it. What are you? Like, what is the you that's listening to me right now? Have a real crack at it. Are you your body? Can't be. You replace nearly every atom in your body every 7 years or so, and you still feel like the same person. Are you your memories? Can't be that either. You've forgotten what you had for breakfast last Tuesday, and you haven't ceased to exist. Physics has its own answer to this, and it's going to sound boring at first, but I promise it gets terrifying very fast. Physics says you are a pattern of energy, of matter arranged just so, and crucially, and this is where it all starts to go off the rails, a pattern of information. And here's where the trouble starts. Because in physics, there's this little thing called the first law of thermodynamics. You would have heard the line, energy can't be created or destroyed, only transformed. Every single atom in your body, the carbon in your bones, the oxygen in your blood, the iron in your red blood cells, has been around since the universe was a baby. And every single one of those atoms will keep on existing long after you stop calling yourself you. Yeah, all right, you've heard the "we're all stardust" line 1,000 times. That's the boring bit. Stay with me, because here's where physics properly gets its hooks into you. There's a deeper conservation law than energy. It's called the conservation of quantum information, and it is the strangest, most stubborn rule in all of physics. The idea is this. Quantum mechanics, the rulebook for everything tiny, says that the information describing any system can never, ever be properly destroyed. You can scramble it, you can spread it across the universe. You can burn a book, and the information that was in that book, the exact arrangement of ink molecules, the wobble of every atom on every page, that information is technically still there, woven into the smoke, the heat, the photons that flew off into space when it burned. Stephen Hawking actually got into one of the most famous fights in modern physics over this exact thing. He worked out, back in the 70s, that black holes should destroy information. You chuck a book into a black hole, the book is gone forever. That was his original claim. And the physics community lost their collective minds. Because if information can be destroyed, the entire foundation of quantum mechanics collapses. Hawking eventually conceded he was wrong. Most physicists now reckon the information leaks back out, scrambled into Hawking radiation, but it gets out. The universe, somehow, refuses to forget. Now, why does any of this matter for you, sitting on your couch in Brisbane or Melbourne or wherever you are tonight? Because you are information. The exact arrangement of atoms that makes you, you, every memory you have, every dumb thought you've ever had at 3 in the morning, all of it is encoded in the quantum state of your particles. And physics is telling you, loud and clear, that this information can never be permanently destroyed. When you die, your body breaks down. The atoms scatter. Some get eaten by worms, some go into plants, some eventually drift up and end up in the atmosphere. Some get breathed in by a kid who isn't even born yet. But the information, the pattern that was you, gets imprinted on every single particle you ever interacted with. The photons that bounced off your face this morning are now travelling out into deep space at the speed of light, carrying a quantum imprint of your face with them, forever. The universe has a recording of you, and there is no delete button. I told you it gets weirder. Now, here's where I have to be properly honest with you, because Feynman would have hated me skipping past this. A lot of what I just said is interpretation. The conservation of quantum information is real and well tested, but what it actually means for personal identity, whether the information being preserved is the same as you being preserved, that part, mate, that's open. Physics doesn't have a tidy answer. What it has instead is something stranger. It has the many worlds interpretation. Quantum mechanics, the actual maths of it, has this awkward feature. Every time something can go more than one way, and at the atomic level, that's basically every event, all the time, the universe might split. One version where the electron went left, one version where it went right. Both real, both happening. And if that's true, and a lot of very serious physicists, including some at our own ANU, have argued it is, then there is a version of you for every possible thing that could have happened. There's a you who took a different job. There's a you who stayed in for that party in year 12. There's a you who actually said the thing you wish you'd said in that argument 3 years ago. And, far more uncomfortably, there's a you who survived every single accident that could have killed you. There's a thought experiment called quantum immortality, and it goes like this. Imagine you're in some impossibly dangerous situation. Doesn't matter what, just picture it. In every branch where you die, you obviously don't experience anything. There's no you there to experience. But in the branches where you survive, by sheer ridiculous quantum luck, you keep on going. So from your own first-person perspective, the only perspective you ever actually have, you can never experience your own death. You always find yourself in the branch where you happen to survive. Sounds great, right? Sounds like a get-out-of-jail-free card from mortality. And this is the bit where everyone leans forward and goes, hang on, that's actually amazing. But sit with it for a second. Because what does that future actually look like? You'd find yourself statistically getting older and older, surviving accidents you absolutely should not have survived, watching every person around you die normally, while you, somehow, keep waking up the next morning, decrepit, confused, outliving every person you've ever loved, again and again, in the only branches you ever experience. That's not heaven, mate. That's a horror film with no end credits. And here's where I have to slam the brakes for a second, because I do not want anyone watching this to take the wrong message. This is a thought experiment. It is not a reason to take risks. The physics here is hotly debated, and even the physicists who take many worlds seriously will tell you that betting your real life on it is, in technical terms, an extremely stupid idea. The point isn't that death isn't real for you. The point is that physics, when you push it to its limits, refuses to give us the simple, comforting answer we instinctively want. Right, deep breath, because we're about to go to the strangest place this whole idea takes us. There's a theorem in physics called Poincaré recurrence, and it says, in any system that's finite in energy, finite in space, given enough time, every possible arrangement of that system will eventually recur. Every single one. Now, here's the kicker that should make the back of your neck go cold. If the universe is finite in some way, and a lot of physicists think it is, then given a stupendously, mind-bendingly long amount of time, we're talking numbers so big the word billion is an insult, every arrangement of atoms that has ever existed must, by the maths, happen again, including the exact arrangement of atoms that makes up you right now watching this video. Not a copy, not a memory, not someone like you, with your memories, Your scar from when you fell off the bike when you were 9, the song that's stuck in your head right now, all of it, reassembled somewhere, sometime, and then again, and again, and again, forever. That's the sentence that should make the hairs on your arms stand up. Not because it's spooky, not because it's mystical, but because it's a logical consequence of physics laws we already trust. The universe, at its deepest level, doesn't really do permanent endings. It does pauses, very long ones. So here we are. Physics has accidentally cornered itself into a position where the simple, comforting answer, you live, you die, the lights go out, doesn't quite hold up. Energy says your atoms persist. Information says your pattern persists. Many worlds says some version of you keeps going. Poincaré says you, exactly you, will reform somewhere down the timeline. None of this is religion. None of it is promising you a soul or a heaven or a place where the people you've lost are waiting. It just refuses, point blank, to let you properly leave. And that's the genuinely terrifying bit. Because we're built, biologically, psychologically, for endings. We need them. The whole reason this life feels precious is that it stops. And physics, with its cold equations, is hinting that maybe the stop isn't a full stop at all. Maybe it's just a comma. Now, and this is the Feynman bit, the bit I really want you to take with you. None of this should make you take this life less seriously. If anything, it should make this exact moment, this version of you, this one specific chance to be conscious and curious and actually alive, feel 100 times more important. Because this is the slice you remember. This is the slice where you decide what kind of person you are. The other slices, the recurrences, the branches, they're not you in any way that helps you right now. This one is. So go and live in it, properly. Talk to the person you've been meaning to call. Have the brekkie outside. Pick the harder, more interesting thing. If your brain is buzzing right now, that's the right reaction. Drop a comment and tell me which part broke you the hardest. Was it the quantum information thing? Was it many worlds? Or was it Poincaré recurrence? I'm reading every single one. Smash the like button if you reckon your friends need to have their afternoon properly ruined by this video too. And hit subscribe because next time we're going somewhere even weirder. We're tackling whether time itself is real, or whether it's just a very convincing illusion the universe is running on you. Cheers for hanging out, mate. I'm Abdullah, this is Curious Physics AU, and remember, stay curious.